I'm recently retired professor at Lancaster University. My professorship is in science studies, or science and technology studies as it's nowadays called, which really means the sociological, historical, philosophical and political understanding of science in all its glorious variety, but including in particular science as it's used in attempts to gain political authority or policy authority or public authority perhaps, which is very different from science as research science, and that distinction is not as clearly recognised and remembered as it should be in dealing with science in public domains. My main cluster of research interests over the last 30-40 years has really been on how to understand scientific knowledge in public arenas. One of the most important such public arenas involving science over that period when I happened to have been developing my academic career has actually been the field of risk. And so what I was looking at there, initially actually in the domain of nuclear risk and energy, latterly more in the domains of environment and agriculture and food in particular. But the same kind of strategic interest in looking at how scientific knowledge as used in those domains of public policy has been constructed, what the assumptions have been in constructing that knowledge, what the framing commitments have been which have shaped the questions, if you like, or the scientific agendas, and ignored some important questions from those explicit scientific agendas. One of the most important kind of omissions in that is actually what you find when you diagnose risk carefully and thoroughly, rigorously, if you like, in scientific terms. Then you find that actually you're into domains which lie beyond risk, such as uncertainty, ignorance, unpredicted consequences of things which maybe couldn't have been predicted or were just simply overlooked, and which current risk assessment ignores, even denies in effect. And then also the qualities of contingency or indeterminacy which beset every single situation in which we're trying to develop scientific knowledge in order to inform public policy. But another general problem in these domains is the way in which scientific knowledge, supposedly and claimed to be independent in advising these kinds of arenas, has actually become committed, normatively speaking, to a particular policy side or agenda or outcome. And so its neutrality or its impartiality, and therefore its trustworthiness as independent, impartial advice for policy, has become compromised, let's say. In the climate domain, I've worked on climate really since the early 1990s, initially looking at scientific models, GCMs or general circulation models, the kind of apex, if you like, of the top science of climate change, but integrated and connected in all kinds of ways with various sort of forms of climate science, climate-related science. My take on uncertainties in that domain, I think obviously it's a long story, but one of the issues which I think has been important is the ways in which the Intergovernmental Panel on Climate Change, or the IPCC, has attempted, largely because of criticism and attack which it was getting, it's attempted to actually deal with the uncertainties in the various bodies of science which it's trying to synthesize in its assessment reports. By being more explicit, being more systematic, being more consistent perhaps in dealing with uncertainty in all of the chapters, all of the topics which those assessment reports cover. But it hasn't really it hasn't been able to go to the full extent of covering all of those different dimensions of uncertainty which my own work has shown in domains like this. And part of the issue there, I think, is political credibility. It's a very political context, of course, the climate issue. And also, so there are uncertainties in the scientific models, for example, which aren't fully addressed and explained and articulated in the assessment reports, because the assessment reports are actually attempting to do a different job than to be fully reflexive in that way. When one looks at the question of why the IPCC feels it necessary to go on elaborating with greater and greater precision more and more variables and relationships included in those models in order to generate something which they would hope is political authority and public authority for that science, then we see a syndrome going on which isn't very healthy, which is that every time the scientists find that their authority is failing, their only response is actually to intensify the science, to make it more precise, to give it greater scope, to give it more precision, to include more variables, to make it more complex. All of those things are laudable if one's doing research science, but they're not doing research science in this context. They're actually doing policy science, policy advisory science, and that's serving different aims from research science. So this is a confusion which exists, frankly, in the whole domain. And I think it's fair to say that actually the basic principles of thermodynamics and quite simple physics, which actually allowed Arrhenius back in the 19th century, and John Tyndall, the British physicist, and others, to say very simply, from very simple models at that time, that if we double the greenhouse gases in the global atmosphere, significant things are going to happen. And, you know, with an overall warming because of the absorption of energy that causes in the large, in those processes, we're going to destabilise the climate, or we're going to disrupt the climate in ways which we're not going to be able to predict in any detail, which we still can't predict in any detail at the levels which matter to human societies. That we don't need to go to the extent of the scientific complexity, attempted precision and accuracy and so on of those models that we're now using with the IPCC and so on, in order to know, for policy purposes, that we need to act on the human influences on climate change. We don't need that elaborated scientific panoply that we've now got thanks to the IPCC. We could act if we were a democratically mature, informed society. We could act, and we should act, I would say, on the grounds of much simpler scientific demonstration that we've got a problem. So that's my take on uncertainty, that the diagnostics of uncertainty are very important, but they're important for different reasons than from those which have been dominant in the climate debate and around the IPCC and so on.